Hi everyone, my name is Christy Pu. I'm a professor from the Institute of Public Health, National Yangming Chiao-Tung University, and I'm going to talk about difference in differences today. Welcome to the session of difference in differences. In this video, we are going to introduce the application of DID and how to implement this estimation using regression method. Suppose you are interested in measuring the effect of a payment policy on employment, and you have data on the employment rate before and after the policy year for both the treatment and the control group. How would you approach the analysis? The first possible approach is to take the difference in employment rate before and after the policy for states with the policy. Can you suspect any problem with this analytical method? Here is a graphical illustration. The blue line represents the employment rate for the states with the policy, and the red line represents the employment rate for states without the policy. And we have data for both pre and post policy year. The first approach basically is looking at the distance here shown in the diagram. However, this distance does not necessarily represent the true effect of the policy on employment for the simple reason that this change in employment rate may just be the result of a time trend, meaning that you may still observe this trend even if there was not a policy. The second approach is to compare employment rate between the treatment and the control group. Here's the graphical illustration. The distance here shows the difference in employment rate for the two groups in the post-policy period. However, this distance here again does not necessarily represent the true policy effect because it is clear the two groups have some baseline differences, meaning the employment rate was different before the policy implementation to begin with. So what to do? Well, the ideal way is to perform a quasi-experimental design where we assign a counterfactual to the treatment group. Here is the graphical illustration. So from before, we know that this distance here is not the true policy effect, nor is this distance. Instead, we assign a counterfactual to the treatment group using the trend of the control group. This dotted line here represents what would happen to the employment rate for the treatment group if it has not implemented the policy. The true policy effect, or the magnitude of the policy, that is this distance here. This distance takes into consideration both the time trend and the pre-existing differences between the two groups. Let's look at an actual study. In this study, we want to find out the effect of building an incinerator on the housing price. Intuitively, having a garbage incinerator nearby your house is not a good thing because it is likely to depress the housing price. In 1978, people knew the government was going to build an incinerator, but they didn't know where until 1981. In 1981, since the location of the incinerator was already known, the dampening effect of the incinerator on housing price should have already manifested in that year. Assuming houses less than or equal to 3 miles are to be affected, and let's call this variable near INC, we can fill back the data retrospectively to create this variable, indicating which house should have been affected. So the incinerator does affect housing price negatively. However, is the decrease in price all caused by the incinerator? This is unlikely for the same reason that we talked about before. The change in the price may be due to either time trend or some pre-existing differences for the houses. Specifically, the construction does not appear randomly, such that houses near the incinerator were in the worst location in the first place. And these houses may have a lower future price even if there was no incinerator. Let's look at some actual data. These figures were derived from the true retail market at that time. Retail price in 1978 for those near the incinerator was around $63,000. Retail price in 1978 for those not near the incinerator was around $82,000. We can see that even before people knew where the incinerator was going to be built, the retail price for those houses near the future incinerator was already lower, meaning that there was a pre-existing difference for the two groups in the first place. Let's look at the retail price after the incinerator was built. Retail price in 1981 for those near the incinerator was $70619. and the retail price in 1981 for those not near the incinerator was 101,308. We see the retail price for houses near the incinerator was lower compared with those that was far from the incinerator. However, this difference, which was 101,308 minus 30619, is not the true incinerator effect for two reasons. First, as we mentioned before, there was pre-existing differences for the two groups in the first place. Second, this difference may well be due to the time trend over the 3 years. Let's plug in these numbers using a 2x2 table. For houses near the incinerator, this row shows the average retail price before and after the incinerator was built. And this row shows the corresponding retail price for houses far from the incinerator. Now let's look at the column for 1978. In 1978, the average price for those near the incinerator was 63692. Just remember that in 1978, there was actually no incinerator. However, even without the incinerator, we can see that the average price for these houses was already lower compared with houses far from the incinerator. This is the location effect. It is unlikely the government will want to build an incinerator in the busy city center, where the average price for houses is high. Instead, the government probably would prefer to build the incinerator in a rural area. The average housing price is likely to be lower in rural areas, even without the incinerator. In 1981, the incinerator was already built, and the difference in the average housing price for the two locations were caused by a combination of the location effect and the incinerator effect. Let's now look at the retail price for houses near the incinerator again, but this time we look at them across the two time periods. For these houses, the average retail price has increased from 63692 to 70916 over the years. Note that this increase was caused by two effects, namely the time trend effect plus the incinerator effect. The time trend effect means that over the years, houses in rural areas are likely to increase in price despite they were in a bad location. The incinerator effect is the change in price due to the incinerator. You cannot distinguish one effect from the other using these two numbers alone. Let's now look at the average price for houses far from the incinerator. For these houses, we can see that the price increased from 82517 to 101307. That's a change of 18790. Since these houses were far from the incinerator and could not be affected by the incinerator, we know that this increase is only affected by the time trend. Now we simply subtract the number like what is shown in the table here. We can get a change in the average housing price purely due to the incinerator. Note that you can do this row-wise or column-wise. Both give you the same DID estimate. Note that we can do this subtraction to get the final incinerator effect is because we assume the time trend is the same for both houses near and far from the incinerator. To put in other words, we assume if there was no incinerator, those near the incinerator would follow the market trend, and the trend is the same for both types of houses. So let's reiterate this assumption again. The parallel assumption means we assume people in the treatment group would be the same as the control group if they were not treated. Similarly, people in the control group would be the same as the treatment group if they were treated. Let's use again the incinerator example. This means we assume the market trend would be the same for houses near and far from the incinerator. Now let's look at how can this be done in a regression context. Why regressions? We need to use regression because we want to estimate a standard error for the DID effect, so we can tell whether it is statistically significant. In addition, we may also want to control for other variables. In the incinerator example, size of houses, the number of rooms can also affect market trend, and thus we may wish to control for these variables. The regression for DID is very simple. You simply put a variable indicating the period before and after the incinerator. This is this after in the regression. In our example, 1978 would be coded 0 and 1981 would be coded 1. Then you put another variable indicating which houses were affected by the treatment, which is this near INC variable. Finally, you put an interaction term for the two variables, which is this after multiplied by near INC variable you see here in the slide. The DID effect will be delta 1. Note if you have other control variables such as number of rooms and how far the house is from the train station, you simply add these variables in the regression. The DID effect is always represented by delta 1. Here is a general specification for DID regressions. DID is very useful given the data fit the requirement. Namely, you have two groups of people or houses in our incinerator example. One group is affected by the treatment and the other is not. And for both groups, you have data before and after the treatment. And of course, the parallel assumption holds. You can do some addition and subtraction here to see what each coefficient represents. In summary, you simply interpret delta 1 to determine the average treatment effect. And this is the end of this lecture.